Further, I want to start by again thanking our sponsors, Molex, IQ Agent, and SAP for their support of this event. Also, a huge thanks once again to Hanover Fairs USA and our partnership with them for being able to put on this day-long event. Finally, there have been, while I get to stand up here and do all the speaking, there have been many more people behind the scenes helping to pull all this together. None of them stood taller than the young lady here to my right. Come on up here, Kristen. Yes, come on up here, Kristen. They can't see you otherwise. Kristen Nimmo has really done all of the heavy lifting behind the scenes, and she deserves all the thanks and praise for today's presentation. Kristen's done a tremendous job pulling all of this together. Thank you. Thank you. Even if the Chicago Bears weren't disappointing and the Cubs and the White Sox were awful and the Bulls were hurt and the Blackhawks failed to repeat as Stanley Cup champions, even if all of that hadn't happened, the biggest news story of 2014 still would have been the location of the Digital Manufacturing and Design Innovation Institute in Chicago. It was big news all over the world, and it was big, big news in Chicago. And we are so pleased to have Dr. Bill King to talk to us today about this program and about what's already here and what's to come. He's the Chief Technology Officer at the Digital Manufacturing and Design Innovation Institute in Chicago. He's also the College of Engineering Bliss Professor at the University of Illinois in Champaign. He's received a PhD from Stanford University and completed the program for leadership development at Harvard Business School. So those are three fairly decent institutions of higher learning. At U of I, he led a research group whose work crosses boundaries between science, technology, and business. He was named by Technology Review magazine as a person whose innovations will change the world. He's been published in more than 180 journal articles and is a fellow at ASME and AAAS. It is our distinct pleasure to welcome Dr. Bill King.
Thank you so much. Well, good afternoon, and thank you for being here this afternoon, making it all the way to the 3:15 presentation. I'm so grateful you could all make it. So perhaps this is a silly question after that introduction, but just a show of hands. Who in the room is aware that the federal government, the U.S. federal government, is standing up a series of manufacturing innovation institutes across the United States with the goal of increasing the nation's manufacturing competitiveness? Show of hands. All right, very good. So, in fact, this is happening. One of these institutes is here in Chicago, the Digital Manufacturing and Design Innovation Institute. On February 21st, President Obama announced that Chicago would be home to the Digital Manufacturing Institute. And we've been working for the last 6 months to stand up this institute. So just a little background, the way that this Manufacturing Institute came about, and in general the Manufacturing Institute project at the federal level, is that the business leadership of the United States went to the federal government and said, we are not as competitive as other nations in the manufacturing sector. There are other nations that are more competitive than we are, that are better than we are at accelerating new technologies to market in the manufacturing sector. So the best example of this is Germany with the Fraunhofer Institutes, but other nations that are very good at this include the United Kingdom, Singapore, Japan. So these are places in the world where there are public-private partnerships, where industry and government come together to pool their resources to identify particular technologies of interest and to accelerate these technologies to the marketplace in a way that makes the participating industries, the participating nations more competitive. So the United States has not played in this space. We have a different way of doing things. Over the last couple of years, these institutes have been stood up as America's answer for manufacturing, for the manufacturing sector. What can we do in the American way to make American manufacturing businesses more competitive? These are very early days for the institutes. Today there are 4 manufacturing innovation institutes. One of them is in Chicago. The other institutes are in different parts of the country. Of the 4, one of them is a pilot institute that's been around for about 2 years, and more recently these 3 new institutes since February. have been around and are just getting started. So this is early days. It's a big experiment. I want to tell you our story about what we're doing here in Chicago and what is our vision for advanced manufacturing. So this was at the White House on February 21st. So actually, this is, for me, my personal greatest achievement, professional achievement of my career. I orchestrated getting this helicopter engine into the White House. So this is a Rolls-Royce helicopter engine. Rolls-Royce aircraft engine is part of our consortium. They're interested in digital manufacturing. They're investing in our institute. And we brought this Rolls-Royce engine to the White House as part of the announcement. So in the days that led up to the White House announcement, orchestrating the delivery of the helicopter engine, I was on the phone with some senior Rolls-Royce executives. And we were talking about what display we were going to take to the White House to talk about digital manufacturing and what does it mean to do digital manufacturing on a helicopter engine and so on. And so they had proposed this engine demonstration as something that we could take to the White House. So I'm on the telephone with this big group of executives, and I say something like, it has to look like a real engine. It can't look like a science fair project next to the president. I want an engine that looks like it could turn on and actually work like a real engine. That's what I said. Now there's a big room full, a conference room, big table, executives sitting around it from Rolls-Royce. They're trying to decide what are they going to do to showcase their product in front of the President of the United States. And what they heard come out of the phone was much different than what I actually said. What they heard was, we're going to take your engine to the White House and turn it on. That's what they heard me say. So it took quite some time for me to walk back the statement and explain what I actually meant rather than what they heard. So the announcement was great. Our government program managers, one of our supporters from the government side, before this announcement explained to the president that digital manufacturing is like the technology that you see in the Iron Man movies, where the character Tony Stark talks to his computer and builds things digitally, and how robotics will assemble the Iron Man suit and so on. And so on the spot, the president came out to the podium and said, "We are building Iron Man." Well, this was great. This is great news, but I'm the chief technology officer of the Institute, and actually the president made me personally responsible for building Iron Man. And I found this out at that moment. And so I kind of had a oh no moment. How the heck are we going to cash that check that the president just wrote? Our consortium has a headline number of $320 million. So this is $70 million of federal investment. This is federal money that has already been allocated for manufacturing technologies. It's being directed towards our institute. About $100 million from industry partners. These are big manufacturing companies. You see the logos on the right. Our dozen Tier 1 and Tier 2 industry members. So together, they're bringing about $100 million forward. We have the rest of the funds are coming from the state of Illinois, city of Chicago, many research universities. We have about 30 universities in our consortium. 6 of the top 20 engineering colleges in the country are part of our consortium. We have our educational partners every year graduate 12% of the nation's engineering and computer science graduates. So if you're going to move the needle on the national scale, this is the way you do it. You bring the best people around the table and you link arms. Overall, our consortium reaches more than 200,000 people. So I want to talk about the macro forces that have gotten us into where we are today. So just some historical perspective. We're all familiar with these kinds of images about historical manufacturing, Henry Ford style assembly lines. The situation today is actually not much different, with a linear progression through design, make, deliver, the commoditization of labor. So the challenges that manufacturing companies have has not really changed in the last 100 years. but there are many forces on manufacturers that have evolved for a very complex landscape. Materials have gotten expensive globally, and there are constraints in moving materials from one place to another. Globally, there is an overcapacity in manufacturing production capacity, and so this has drained the profits out of the manufacturing sector. Labor is expensive. Even in what was formerly known as low-wage labor markets, labor costs are rising everywhere. In particular, labor costs are rising very quickly in other parts of the world, which formerly had low-wage structures. And there's a skills gap globally. If you talk to manufacturers at this show, they'll talk about a skills gap in North America, they'll talk about a skills gap in Asia, they'll talk about a skills gap where they're making things. And as you talk to manufacturing industry leaders, what they will say is that they see the skills gap growing over the next decade and more, and they have no idea how they're going to remedy the skills gap. So it's a problem that today is painful and that everybody knows is going to get worse. You can't open up a newspaper or magazine without hearing about outsourcing, offshoring, reshoring, onshoring, nextshoring, lots of buzzwords. But for more than a decade, we have separated designers and makers. So the people that design things are no longer located with the people that make things. And so this way of doing business has driven costs, and these costs have been hidden for a long time. So you'll design something and you have to jump on an airplane to go talk to the person who's going to make it. Maybe you have to go overseas. And of course, the first prototype that you get isn't right, so you have to take another overseas trip. Takes a long time to get your first 10,000 parts where you want them to be. Across the manufacturing sector, there are barriers for sharing data and information. So these barriers are technical, but they're also on the people side of things, skills, the way that people are incentivized, the way that organizations are designed and they behave, and then of course all of the security, intellectual property, and trust issues that come with digital technologies. So today, there is a very complex landscape around manufacturing. So what will manufacturing look like in the future? So the future of manufacturing will be digital. There will be deep digital links between designing and making things. Machines, factories, and supply chains will be hyper-connected. You will have transparency into factories in your organization. You will be able to see into the factories of your suppliers and track the fabrication of parts all the way through your supply chain. There will be aggregation of data across the life cycle of manufactured products, and that data will be used. So the future of manufacturing looks like Iron Man. So actually, the president got it right. It will look like Facebook. It will look like LinkedIn. It will look like Google. Today, manufacturing generates more data than any other sector of the economy. So here we've combined both discrete manufacturing and the advanced manufacturing enterprise, the extended manufacturing enterprise in this top bar. But actually, if you just take either of those, you still get the biggest biggest pole in the tent. So any way that you measure it, manufacturing generates more data than any other sector of the economy. When we talk to manufacturing leaders, they say most of the data we throw away. When we keep it, we don't know what to do with it. So digital manufacturing is the aggregation of data across the life cycle of a manufactured product. So if you think about the life cycle of a manufactured product, starting all the way back in the first idea that you have on the back of a paper napkin. So that idea is turned into a computer model. It's broken down into parts, perhaps. Those parts are sourced from different parts in a supply chain. Perhaps the supply chain is complex. The parts are brought together into sub-assemblies and assemblies. They're checked for quality. At every step in the life cycle of this product, data is generated. Data is generated when you sell the assembly to your customer. Data is generated by the product in the hands of your customer even after it has been sold. So data is generated all the way until the product reaches the end of its life or it's reused or recycled. Digital manufacturing is the aggregation of data across the life cycle of a manufactured product. It's the way that we do analysis on that data. We turn the data into information, and we turn the information into value. And so this is the vision for digital manufacturing within the DMDI Institute. Our technology thrusts are broken out in the following way. Advanced manufacturing enterprise is really in our lexicon, it's the information systems across the product life cycle. So it's the way that data is exchanged across the entire enterprise. It's the digital links between designing and making. It is information systems within a factory, between factories within a supply chain. Intelligent machines is the sensorizing and computerizing of fabrication equipment. It's bringing intelligence and computing to the shop floor. It's making machines self-aware, the technology that allows machines to talk to machines within a factory. Finally, advanced analysis. It's the computing engine. It's the algorithms that are the engines for making all of these calculations and analyzing the data that's generated. We have two additional technology tenets in our institute. The first is what we refer to as the Digital Manufacturing Commons. So our key innovation is that we are developing an online collaboration platform that is going to allow small businesses to aggregate their data in a cloud computing collaborative environment. So this is an open source, free to use digital manufacturing environment. All you need to do is open up your web browser. You can start to upload data, interact with other manufacturing businesses, get access to computing analysis tools. So we will have a public launch of this Digital Manufacturing Commons before the end of the year. So if you are interested, we would love to have you as a participant. Please come to our website, get signed up, and you'll hear an announcement in the next couple of months. Finally, I just want to mention cyber-physical security. So if you're going to connect all the machine tools of the world to the internet, how am I going to keep all that safe? How am I going to keep my competitor from seeing what I'm doing in my factory, and so on? And so the security part is critical and runs through all of this activity. I want to talk about the guiding principles that our institute has adopted as we stand up our operations. The very first principle is, what is the business need? So DMDII is focused on applying technologies that solve business problems. And so we have been working with our industry partners who are bringing a lot of money to the institute to have crystal clear understanding of what is the business problem that is being solved, where are the value opportunities that can be unlocked with digital manufacturing technologies. We have industry leadership. We also have a diverse team. We have universities, public sector partners. We have lots of smart people that have come to the table with ideas and things that they want to contribute. So this is a public-private partnership, and our diversity gives us great strength. We have worked to co-create the value proposition with all of our partners. So digital manufacturing is a multi-trillion-dollar opportunity. There is enough value here that everybody can have all they want, and then there's more left over. So this is not a competitive environment. This is a collaborative environment where we have built this coalition where everybody's arrows are pointed all in the same direction, and we're collaborating in coming up with the value proposition so everybody can get what they want out of this and more. We are building a roadmap and a strategic investment plan, which I will describe. As we started to think about our technology roadmap, we surveyed our partners I have results from a survey that we did of 170 leaders in industry and academia in the area of digital manufacturing. So one of the key questions, a couple of the key questions that we asked are represented here. The result is staggering. 80% of the 170 manufacturing leaders that we surveyed, 81% said that digital is essential to their future manufacturing competitiveness. 14% said that we are digitally capable today. So there is a huge appetite for digital technologies in the manufacturing sector, and there is a huge gap between present state and desired future state. So in one slide, this tells you why do we need to have an institute dedicated to digital manufacturing. It's to solve this problem right here. Here we have just a description of how we went about building our technology roadmap. As we think about the value drivers across the value chain, there's just some examples of things that people stepped forward and said, here's where we can make money with digital manufacturing. Starting with new business creation, new business services, through collaborative innovation, crowdsourcing in the product development phase, in sourcing, there are opportunities in identifying suppliers, having supply networks synchronized and working together, cost transparency, digital tools for determining what should something cost before I actually place a purchase order. Digital tools in production, real-time data collection analysis, advanced analytics on the shop floor. Supply chain management tools, synchronizing supply chains across end-to-end product lifecycle. After-sales service, a huge opportunity bucket for maintenance, product tracking in the field, and then using end-of-life events to pull forward new design innovations. So we asked our industry and academic leaders, what are the most important priorities? You can see the color coding here. The dark blue represents the biggest buckets of value: new business creation, product development and R&D, production, capital and resource productivity. So digging in now, here we have just an organization of what are the biggest market pull areas for digital manufacturing. The number one on the list is product design and development. So manufacturing leaders see that modeling and simulation tools, virtual prototyping, cloud computing, manufacturing, design analytics can all be brought to bear to bring new product designs to market faster. And so the new product designs and accelerating new products to market are then linked to increased customer satisfaction and overall increased competitiveness of the firm. But there's also value from operations and capital productivity. So factories that can do more than one thing, factories that can change from one thing to another more rapidly, factories that can operate at higher capacity utilization all the time. So we organized the value drivers into this value tree. So what we are doing here is developing the business case for digital manufacturing so that our industry partners and our government and academic partners can go back to their organizations and have clear value stories about what is the ROI for digital manufacturing. So advanced manufacturing or technology-driven manufacturing has for a long time told the story about cost reduction, productivity improvement, and perhaps higher capital utilization. So we have all of those categories here. Digital manufacturing does give you cost reduction. It does give you higher capital productivity. There is something here that is new, And the thing that is new is that we have revenue improvement. So manufacturing doesn't have to be on defense anymore. Manufacturing can go on offense. Manufacturing technologies, digital manufacturing technologies, are a source of revenue growth, new business growth. So the way that comes about is through increased customer satisfaction, new product innovation, bringing new products to market faster than you otherwise could, higher product availability, more uptime, using your factory more of the time to do more things, expanding your revenue of existing business. So what we have heard from the industry partners in our institute is that this is not the same old story about how does technology make manufacturing better, that there is a thing that is new here, and that is that you can grow your business with digital technologies. And so the technology is critically important. We are a technology institute. Technology by itself will not solve the problem. So how do you get people to actually use the technology? And so there is a big piece of the equation that is the people side of things. So what is the strategy for deploying digital manufacturing technologies? How can you translate that strategy into action? How can I design my organization, create the incentives, the organizational structure, and put people with the right skills in the right places in order to take advantage of digital technologies? And how can I get my organization to use data in a manufacturing environment? So this people, organization, and culture side is critically important. And we are cooking these ideas into all of our R&D activities so that we don't just have technology development, but we have technology adoption by our partners. I want to give 3 examples of projects that we have envisioned for the Institute, and we are in early stages of kicking off these projects. The first project is real-time shop floor advanced analytics. So this is a team where we brought together 2 U.S. manufacturing companies, aerospace company, top engineering schools, a software firm, to collaborate on developing a tablet computing-based shop floor analytics engine that uses the vision system, the camera in the tablet, to take images of an assembly in production and create real-time dynamic work instructions for a technician on the shop floor. So this is a great example because all of the technologies involved are on the shelf. They're available in the world. They have not been brought together to do this particular thing. We have partners in our consortium that understand the technologies, they understand the problem, they have use cases where the technologies can be demonstrated. And so this is a project that we envision to bring all these things together. The example impact for this particular project, reduced rework, reduced labor costs, saving about 30% costs in this particular step of the production process. This is an aerospace platform that we had envisioned. So this particular platform, for every 1 hour that you can save in the production process, you save $1 million over the life cycle of that particular aerospace platform. So there's huge value to be realized with this technology. Let me quickly go through the other 2 examples. The second one is bringing intelligence to machines for geometric adaptive machining. The example is a casting application, large castings. There's very high scrap rates. And the state-of-the-art machines are not capable of following the steel. They follow some theoretical geometric path that the steel may or may not conform to. So the concept here was to bring together vision, metrology, real-time computing, analytics that connected the shape of the casting with the capabilities of the machine tool so that the machine tool could follow the steel rather than just follow the geometry. So we estimated a reduction in scrap rate by 50%. Finally, we have an example project where that's based on cloud computing-based collaboration between an aerospace OEM and its supply network. Today, it exchanges data with its suppliers by fax machine. In some cases, the suppliers are very digitally savvy and they can email a PDF back and forth. And so this is a demonstration where we're going to bring the small businesses online and teach them to collaborate in this cloud computing environment, accelerating new design changes through the supply network. We estimate a cost reduction by 10 to 15%. So finally, as I wrap up, I just want to mention some of the stories that people are starting to tell as we bring this thing together. About next generation product design, we are moving to a story that's not just about cost, but also about growth. People see value in the connectedness to their customers. Digital tools for linking the designers and the makers and for accelerating the design-make loop. Adaptability and resiliency in factories and in supply chains. Using big data, so the application of analytics to turn manufacturing data into information, and the overall agility across the life cycle of manufactured products. Finally, just to conclude my presentation, I want to mention that we are building a facility, we're renovating a facility on Goose Island. It's about 1 mile northwest of here. There is an island in the Chicago River. And I hope that at IMTS in 2 years, we see all of you for a tour of the facility. So with that, I thank you for your attention, and I would love to take some questions.
Thank you very much. That's a exciting presentation. Questions? Yes, sir.
Thanks very much for a fascinating presentation. My name's James Devitt. I'm from the Yorkshire area of England. You did mention other institutions and organisations in Germany and the UK. We've got an advanced manufacturing research centre very close to us, of course, similar.
We would love to grow up and become your peer. That would be great. So,
well,
yeah.
We are looking for partners, of course.
Great.
And one of the thoughts I had was that you were talking about hyper-connected city factories. And my question to you really is, do you see the activity of your institute working in collaboration across the globe as factories will start to do in the future, potentially?
Yes, absolutely. So, the digital part of manufacturing, it's the nervous system. It's the digital thing that's going to connect everybody. So we see ourselves as the beginning of a global nervous system for advanced manufacturing. It's a great question. Thank you.
Just out of curiosity, how does a company or individuals become more involved with your organization to help you meet deliverables or to even vet ideas?
Thank you for asking that question. Somehow I neglected to leave off our website, but you can go to digitallab.uilabs.org. digitallab.uilabs.org. So UI Labs is a not-for-profit started by the University of Illinois with the purpose of setting up collaborations like this one. So UI Labs, yeah, that would be great. So please, I would invite all of you to come to our website, uilabs.org, see what we're doing. You can get signed up, be on our mailing list, and you'll hear about what we're doing. We will have a workshop that is open for all that will be on September 26th. here in Chicago, and we would love to have all of you attend.
Yep.
Thanks, good presentation. Looking forward to the Ironman thing. The question I have is, sometimes the perception when you involve government is a huge bureaucracy and lots of meetings and paper that is produced and not a lot of action. So how do you prevent that perception, or how do you go against that perception and really get some things done and have some achievements perhaps early in the program so that you can point to? And is that one of your goals, or again, I see it, this giant thing built up, and I think we all are interested in seeing action from it as well.
That's a great question. So let me first say that the Manufacturing Institute is a self-governing organization. The government has a role in it, but we have an executive board that consists of our, it's led by our industry partners. There are government partners on it. The Institute is run by an executive director, Dr. Dean Bartels, and he is the executive director. He reports to the executive board, but he has decision-making authority for the Institute. He's not a government employee, he's an employee of UI Labs. I hope that I emphasized that our entire philosophy is to start with the business need and where's the value to unlock, and to direct all of our attention to exactly the points that we can get the best leverage about solving business problems. So that is deep in our DNA. I will say that the federal government has been a great partner, that the people that we've been working with in the government have been coaches and cheerleaders and helpers, and they've done a lot more help than harm, that's for sure.
I had one issue more on the tactical side. You talked about manufacturing and looping back around to design and becoming a circular process. For a long time, it's been loggerheads. You've had design and manufacturing colliding with one another rather than collaborating. What's been the change, and how do we continue to foster that? Digital manufacturing or not, how do we continue to foster a better relationship between design and manufacturing?
Well, you're going to have to pull me off the stage because my answer is like an hour long, because this is an awesome question. So why is this happening now? Why do we have a Manufacturing Institute for Digital Manufacturing? The challenges that manufacturers have, they haven't changed in 100 years. How do you design a product and get it into the hands of your customer as quickly as possible? How do you do so at high quality and make the best use of resources along the way? That reality has not changed for manufacturers. So what's going on? What's new? The thing that is new is that we have computing that is ubiquitous. Today there are 1 billion people connected to the internet. We carry supercomputers around with us on our smartphone. We can access computing anytime, anywhere through our tablets. We have at our fingertips, almost free, as much computing power as you could possibly want. So this is the thing that is new, is that we have computing in ways that has been unprecedented and will continue to grow at an exponential rate. Now combine that with the data that is generated in the manufacturing sector, already more than any other sector of the economy, and people don't know what to do with it.
And I started the discussion first thing this morning by saying that in a global automation and manufacturing summit, we talk about automation and manufacturing. I wanted to talk about global. And this ties all the way back, and it goes to James's question, is manufacturing is no longer a parochial issue. It's no longer a national issue. We're really talking about, honest to goodness, global data sharing and global manufacturing.
So I just want to say that, that our vision for digital manufacturing gives American manufacturing companies a huge competitive advantage. Because we are a nation of innovators, we are a nation of entrepreneurs and tinkerers, and the app economy, the way that innovators can make new software tools and bring them to bear and create value in short order, Americans are the best in the world at doing this. And what we want to have happen is have the manufacturing sector realize the benefits of this computing revolution.
Got a question at the back of the room.
What have you done to assure that small manufacturers participate in this?
So please come to our website. The membership fee for a small business is $500 a year. Our Digital Manufacturing Commons online platform will be free to use, And we have designed it in a way that all you have to do is open up a web browser. You don't have to get permission from your IT department. You don't have to install software. Just open up a web browser, come to the website. There are tutorials online. It's very easy. So we are focused on reducing the barriers as much as possible to get small businesses online and connected and starting to use these tools. I talked a little bit about our research projects. I didn't mention the 3 research project examples, but all of those projects have small businesses that are participating in meaningful ways. And if I have my druthers, every single project that we do will have small businesses participating. I hope you're one of them, so please come.
Are you participating with or joining forces with NIST and the MEP programs?
So we have NIST representation on our technical advisory committee and our executive board, and there's NIST participation in a bunch of different activities, particularly in the model-based engineering space. So Department of Commerce and Department of Defense and Department of Energy are still kind of figuring out how they're going to work together in the manufacturing institutes, and that might change if there's new legislation around these manufacturing institutes, which I mentioned. But at our recent technical advisory committee, we had the head of the MEP program from NIST, who is deeply involved in our road mapping process. So we have the attention from the very top. And we are making our best efforts. Our concept is that these new technologies are demonstrated, developed. We have curriculum that we would develop, and that we would use the national network of the Manufacturing Extension Partnership as our channel for disseminating this information into small businesses throughout the country. So that is our working concept, and we'll see how we can bear fruit. Hey, I got Rolls-Royce and GE both to tier 1. This other stuff's easy.
Any other questions for us? Well, Bill, that's a tremendous start to what I think everybody agrees is a very promising and very exciting program here in Chicago. As a native Chicagoan, it's great to have it here, but it's great to have this kind of a program, and it's a great way to wrap up our program. Ladies and gentlemen, Dr. Bill King.
Thank you. Thank you.
As I said, I want to end this the way we began. I want to thank everybody for their participation, for their involvement today, and we look forward to putting on these kinds of programs in the future. For now, thank you on behalf of everyone involved with CFE Media, Plant Engineering Magazine, Control Engineering Magazine. Have a great rest of today and a great show. Thank you.